This is Intermediate Algebra Lesson 7.6b, Quadratic Functions, Day 2. For our first warm-up, we are going to solve using a t-chart. Remember, this is similar to the absolute value where there could possibly be two solutions. So our first step is to look for any surrounding guards, and I do not see any. So the next step is to get rid of the squared unit by taking the square root of both sides. Now when you apply the square root, the squared number 2 here cancels with this square root. So the only thing left on the left side is x minus 5. On the right side, however, when you take the square root of a number, it could be two possible solutions. The one your calculator shows you, which the square root of 36 comes out to 6, or it could be the opposite sign of negative 6. So what we're doing basically is two t-charts in one. You can split it into two separate t-charts if you want. Next, I want to get rid of the minus 5 by adding 5 to both sides. So I'm going to add 5 to the positive 6 and the negative 6. So in this case, our x is what remains, and 6 plus 5 is 11. Negative 6 plus 5 is negative 1. So our two answers are negative 1 or 11. For the second example, we're going to do the same thing. This time, only the x is being squared, so 3 is acting as a guard. We want to divide by 3 to get rid of it. So we have x squared left. 27 divided by 3 is 9. Because there are no guards left, and we have the squared we need to get rid of, we are going to square root both sides. Now again, on the left side, the squared and the square root just cancel, so x remains. When you take the square root of a number, you get both the positive result from your calculator and the negative result. So square root of 9 is 3 or negative 3. And because there's nothing else with the x, that would be our final answer. The last problem says simplify. This one we are just going to combine like terms. So first we're going to do inside the parentheses here. 4 minus 5 is negative 1. We have the plus 3. Now negative 4 is being multiplied by this negative 5. So I like to change this to plus negative 4, and then we have negative 5. And we can solve this 2 squared. 2 times 2 is 4. So the next step, I'm going to figure out what negative 1 squared is. Negative 1 times negative 1 is positive 1. We will do the multiply before we do any addition or subtraction. Negative 4 times negative 5 is positive 20, and then we have the plus 4. Now because we only have addition left, you can just work from left to right. 1 plus 3 is 4, plus 20 is 24, plus 4 more is 28. Our objectives today are to compare the squaring function with other functions and relate it to finding the area of a square. So steps to solving a quadratic. So we're going to start with getting rid of any guards. So step 1, we're going to get rid of this minus 6 by adding 6 to both sides. I'm going to use this bar here as my t-chart, so I'm just rewriting it. And opposite of subtracting 6 would be to add 6 to both sides. So my new result is 5 parenthesis x minus 2 squared equals, and then we need 39 plus 6, so that's 45. Step 2, we need to get rid of the other guard. This is a multiply. Opposite of multiply is to divide by 5. The 5s will cancel on the left. X minus 2 squared remains, and 45 divided by 5 gives us 9. Now because we have the x minus 2 squared left, we want to get rid of the squared, so our step 3 would be to take the square root of both sides. The squared and the square root cancel on the left, so you have x minus 2 remaining, and on this side the square root of 9 is positive 3 or negative 3. So you could write the x minus 2 twice and have two separate t-charts, or you can just do it as one large t-chart. Last step would be to get rid of the minus 2, so we're going to add 2 to both sides of both t-charts. And the 2's cancel, so we have x equals 5 or x equals -1 for our final answers. In example A, they're asking us to use the functions below to find each of the following solutions. Remember, when the number is in the parentheses, you're just plugging it in and solving. When the number is equal to the function, that's when you use a t-chart. So be careful on this one. Your calculator will deceive you. We have 2 times -4 squared. Notice I kept the -4 in parentheses. So now I'm going to think about -4 times itself. A negative times a negative is positive. 4 times 4 is 16. Now I'm going to do multiply before the addition. So I'm going to do 2 times 16, which is 32, plus 10 more, which is a total of 42. Same example over here, except with a different function. So we have 8 minus 7 squared plus 3. 8 minus 7 comes out to a value of 1. 1 squared, or 1 times 1, is also 1. And 1 plus 3 is an answer of 4. The next problem is an f of x function equaling a number. So I'm going to use the f function from above, this one right here, and set it equal to 28. So x minus 7 squared plus 3 equals 28. Now in this case, we will have to do a t-chart. So first thing I'm going to do is I'm going to get rid of the guard, which is the plus 3. Opposite would be to subtract 3. So this comes out to 25 on the right, x minus 7 squared on the left. Because there are no more guards, we have to get rid of the squared by applying a square root. Now remember, anytime you do the square root of a number, you could get the positive answer or the negative answer, even though your calculator only shows you one result. Okay, now I'm going to continue my t-chart. Notice I just made one kind of funky t-chart. That's fine. Opposite of subtracting 7 is to add 7 to all items. So 5 plus 7 is 12, or -5 plus 7 is 2. Going back up to our last example, it will be a t-chart as well, this time with the h function, which is 2x squared plus 10. So 2x squared plus 10, and it has to equal 72. So I'm going to get rid of my guard of plus 10 first, subtract 10 from both sides. 2x squared drops, and this becomes 62. Next, we're going to get rid of the multiplying by 2 guard, divide by 2 on both sides. X squared remains, and 62 divided by 2 comes out to 31. Now unfortunately, this is not a very nice result since 31 is not a perfect square. So our last step again is to get rid of that squared by applying the square root. Now this one's nice because there's nothing extra, it's just the x. So we're going to get our final result right away. So I'm going to do square root of 31 on my calculator, and it comes out to about 5.56 or 5.57. So we'd have positive 5.57 or negative 5.57. All right, evaluating, remember that kind of means solving or getting an answer, finding the solution. 3 squared means 3 times 3, which equals the value of 9. Notice when I'm squaring a number, there's only one answer. When we apply the square root using a t-chart, there could be 2 solutions. We'll go over to B here. We are going to simplify on the inside first. 4 minus 8 is -4, so we still have -2, absolute value, -4. Now the absolute value of -4 is actually +4, and then we still have that -2 out front. -2 times 4 gives us -8 for our final solution. In letter C, again, we're solving inside the parentheses first. -8 minus 3, it's like I spent $8, I spent $3 more, so that's -11. And then we're going to do -11 times itself, that's the squared portion. Negative times negative is a positive, and 11 times 11 is 121. Simplify inside the absolute value first. 4 minus 3 is 1. The absolute value of 1 is still 1, and 1 minus 8 comes out to -7. Letter E, we're going to simplify inside the parentheses. So we have -5 times 1 squared plus 3. We will do the squaring next. 1 squared is still 1. We're still multiplying by -5, and we're still adding 3. PEMDAS order, multiply comes next. So this is -5 plus 3, which is an answer of -2. On this one, we're going to simplify on the inside first. Absolute value bars stay. -4 times 3 is -12. Then it changes to +12. In example C, it says identify which function is used in each input-output pair. This is a little bit more difficult. So what you're doing is you're testing each equation to see which one is the solution. This first number is your x number. So I'm going to first test the f function with -2, and I'm replacing this x with the number -2 in hopes that the answer of 8 will come out. So 7 plus 4 times -2, and then we would just solve that. 4 times -2 is -8, plus 7 gets me an answer of -1. -1 is not the solution here, so the f function is not correct. Next, we're going to try the g function of the -2 value for x. So that's going to plug in right here. Absolute value of -2 plus 6. -2 turns out to be +2 plus 6 comes out to the answer, of 8. And 8 is the correct solution that we wanted. So G does work. We also have to test the last one because it could be a solution as well. So we're going to test the H function with the number -2 for x. 18 times 1.5 to the power of -2. Now this one's a little bit more complex. I'm going to use my calculator. 18 times 1.5 to the power of -2, and that one also comes out to the value of +8. So this is just plugging in to see which equation is a solution for the problem. There are 3 more of these examples that you can give a try on your own if you want to. The homework is the worksheet following this lesson.